All right, welcome to week 7. We're talking about arrays, and I don't want you to be nervous about these things. We've been talking about them and hinting at them all semester long, and we've shown them in a couple of examples already that you've seen. And really, the benefit of an array is that it simply allows you to store a lot of data under one variable name. And then there's a trick, just using the index or the subscript operator, which is the square brackets, to access each individual element of the array. So to declare an array, it's just like declaring any other variable. You have the type, and the type will consist of both the data type that the array holds and then the indicator that says that we want it in an array. So let's create an array of double numbers, and we'll just demonstrate how this happens. So we'll say double, that's the type that the array holds, and then we say that it's an array. And then just like any other variable declaration, that was the type. And now we're going to give it a name. So we're going to call it double numbers, spell it right. And then on the other side, we say new. That the new keyword in Java allocates memory. So when we say new array, that's going to allocate the memory for the array and store it somewhere in our computer's memory. When we say new string or new objects, when we get to objects next week, yay, then we just know that the new keyword means that we're going to allocate memory somewhere in our computer's memory, and we're going to point to it. So double numbers is going to point to this place in memory that stores our array data. It's a little bit different than when we had primitive types. If we had just had a double, then the memory for that variable is actually stored right there where the variable is declared. But in the case of objects and arrays, the memory gets allocated somewhere else and we point to it. So we have a reference to the data. Doesn't mean you do anything differently when we write our code, but we do have to keep in mind that we're pointing somewhere and we're not necessarily making copies of things as we're passing them around. If we want to make a copy of an array, we have to pass it around as a copy. So anyway, I digress. Let's say new. We're going to say, and here's our type, but the thing we do differently on the right side of the equal sign is we're going to tell it how many of that data type we want to store. So this is going to be an array that stores 5 double values. And then if we want to initialize each value, well, let's actually just show this. Let's do a quick for loop. We'll do a for, and I'm going to introduce the for each loop, because what the for each loop is, we could have done this. We could say for int I equals 0, I less than double numbers dot length I plus plus. So I guess there's a couple of things to note here. Every array has a dot length property that tells you how big the array is. So that's actually very important, because anytime you're working with an array, you need to use the dot length. Even if you know the number, I could have put a 5 here, but it's just safer for me to use the array's length because it always knows what length it is. And maybe I change my requirements and it's not 5 anymore, it's 10. I don't want to have to find every place in my code that I assumed that the size was 5. So just use the dot length property of the array. So then we'll just say system.out.println, and we'll say double numbers sub I. So if I print this out and I run this program here, let's run our creating arrays. And they're all 0. So I said I want a new array of double numbers, and it initializes them all to 0. Because Java doesn't know what numbers we want, it won't automatically do random numbers because we didn't tell it we wanted random numbers. So the only default value it can ever think that might be reasonable is 0. So unless you give it a value, then it's going to assume 0. So let's give our elements a value. So we can say, we're going to say double numbers sub 0 equals 0. Double numbers sub 1 equals 50. And we could put any numbers we want, right? Double numbers sub 2 equals 35.3. I mean, these are doubles, even though these look like integers, because I've declared them to be, because I'm assigning them to a double, Java takes care of turning them into double values. Say double numbers sub 3 equals 100.1, and double numbers sub 4 equals, let's make it 2. So then if I say double numbers sub 5, if I put that 1, I'm actually going to get an error when I run my program. So let's run it and let's take a look. I predict we're not even going to get to where we print out the values. We're just going to get an exception right here on this line 14. So we'll compile it and we'll run, and I get an exception. And sure enough, it was line 14. You can see that there in the exception trace. Java's nice when you're running your programs in the IDE, either VS Code or IntelliJ. When you get an exception, it's actually going to print the stack trace and show you where in the code it was. And IntelliJ actually lets you click it and it'll put the cursor right there on that line. But the problem is described here. Index 5 is out of bounds because remember, arrays are indexed starting with 0. So this would be the first position, second, third, fourth, fifth. So we actually have our 5 values here, but they're numbered 0 through 4. So I can't actually put something in position in an index of 5 in that array because there isn't an index 5. And in Java, you cannot grow an array. The only way you can make your array bigger is to create a new array and copy the data into it from the original array. So arrays are constant in size after you've declared them. All right, so we got rid of the offending line, and now we can run our program again. And we see our values. So we've printed out our values now, and they're not 0 anymore, except for the one that I actually set to 0, and that's fine. I didn't, knowing that it's initialized to 0, I could have omitted that line, but that's just kind of bad programming practice. You want to account for everything. If you're accounting for some of it, you should probably account for all of it. Now, this for loop is perfectly effective at counting the array, but let's take a quick check at this new for each loop. And we've talked about this. We've said that for each loops were coming a couple of weeks ago. There's actually, because this is such a common thing to use a for loop to go through all of the elements of an array, we can cut out the middleman, so to speak, by just saying for double D, so we're declaring a variable, and then there's a colon, meaning of or in, for double D of. If you're coming from the JavaScript world, this would be a for of loop and not a for in loop. This is kind of like a for in loop. This is a for of loop. But we're going to do, and in Java we call it a for each loop. In our double numbers array, and then we'll just copy this line down because we're going to do the same thing here. This just says for every value in double numbers, stick it in a variable named D and give it to me in my loop. And now I don't need double numbers sub I because that's not in scope anymore. I just need my variable D, and that's this D here that I've declared it as my loop variable. So if I run this code now, you can see I have my list here again, 0, 50, 35, then we start over 0. So this for each loop is exactly equivalent to our for int I equals 0, I less than numbers dot length. We tend to use the for each loop a lot more, but the only time that it can be used is when you want to treat every single element of the array. Now, if you decide that you've had enough and you need to break out of a loop, you can break out of a loop. You can also continue a loop if you have some if statement and you say, yeah, I just need to skip the rest of this loop body, then you can continue to go back up. So it works just like a normal for loop. But without doing anything else, you're going to get every value of the array one at a time, and it's going to put it in this variable that you declare here. Okay. So this now, let's just move this code down to the bottom so that it stays in our example when we post it to the discussion board. So this is how you can initialize the values of an array by assigning each value. And if you don't know the values, or if you're reading them in from the user, for example, you might need to do it this way, where you're just going to have to keep going. And you might stick this in a loop where you have a loop counter that counts how many times the user's entered a value. In fact, your assignments this week are going to ask you to do that. And I recommend that rather than having 5 read statements that you put them in a loop with a loop counter, and you just keep going until you've got the 5. So yeah, so let's demonstrate the next thing. So this would, let's say we're going to have it in a loop. And that's pretty much what we were just talking about. So we've got our double numbers. Now let's use a set of integers. So we're going to say int array, int numbers equals new int 5. And I can say for, and let's say I want to get 5 values in there. I can say for int I equals 0, I less than int numbers dot length I plus plus, and then I can say int numbers sub I equals, and then I can set it equal to whatever. If I have a scanner, I could say scanner dot next int. I could say, if I had a random generator, I could say random dot next int. Or if I'm just giving a quick example in a online instruction video, I can say number sub I equals I plus 1. That'll kind of let us see how many things are in the array. So I could do that. That will allow me to initialize a variable. And you can, of course, have logic. If you're using your scanner and the user doesn't enter the right value, then you would definitely say, well, we didn't get a value and we just loop back. Okay, so that prints out our, or that initializes our array. And you can, like, again, and we'll put a comment here just so. The right side can have any Java expression that results in the data type of the array. So I plus 1, if we're using strings, and we would need to have strings, etc. So scanner.nextInt returns an int, so that would work. You know, hopefully I'm not beating that point too much. So that's how you would use a loop to initialize an array. And then there's this thing called a static initializer. And actually, I think for clarity, let me move these up here, because this will, of course, only work with our doubles, because that's what we're assuming here. But now back to our initializer. Java has this nifty way, if we already know what's going to be in the array, all the values that it's going to have, we can actually do this. We could say, and let's do strings this time, we could say string array, strings equals new string array, and then I can put in curly braces my comma separated list of strings, 1, 2, 3. And so that, of course, is how I would, that's the whole array. Now let's just prove our point by doing another for each loop here. We can say for string s in strings system.out.println s. And if we run our program, we'll get our double output first, and then we'll see our string output. So there's our 1, 2, 3, just like that. Now, you can actually get tricky here, and we didn't necessarily have to create a variable to hold it. We could say new string array here, 4, 5, 6. And you can actually, because remember, this is just an expression that results in a string that can then be assigned to our, or a string array that can be assigned to our variable. So this is just an expression that results in a string array that can be used as the array for our for each loop. But if I run this again, voila, 4, 5, 6. So I'll take that example out, but those of you who watch the video will know that it's possible to do that. Sometimes if it's a huge list, of course, we wouldn't do it inline in the loop. We would have it created separately. And of course, these values could come from a database. They could come from a network request. It could come from a file. So the things that we read into arrays can come from anywhere, as long as it's the type that we declared the array to be. All right, and I guess for the sake of completeness, we'll just print out our integer array too, so that it doesn't feel bad. But of course, our for each loop needs to be based on ints. So I'll say for int I in int numbers And if we run our program one more time, we prove to ourselves that it works. There we go. So there's our data. All right, cool. Take a sip of water. Now that we know a little bit about arrays, we have the ability to do some actual work with the arrays. So I want to go through the bubble sort demonstration. We're going to write a bubble sort, and it's simply put, a bubble sort is an array that compares each element of the array to every other element of the array. And if it finds an element later in the array that is actually less than itself, or than the element that we're currently looking at, then it will actually swap the position. So that and we end up passing through the loop. However many there are, we do that squared times. So if there's 10 items in the loop, we're going to iterate over our loop 100 times, 10 times 10, so that we're actually going to have, we're going to be guaranteed that every slot is smaller than the next one, or the value in every slot is smaller than the next one. So that'll make a lot more sense as we see it laid down. But what we're first going to do is we are going to, we're going to demonstrate. I haven't done this before, so you guys are in for a treat, I guess. We're going to use our arguments array that's passed into our main, because we've been using scanner all semester long, and we already know how to use that. And in your assignment, you're going to have to ask the user for those values. But I'm going to give you the option of using arg array and not a scanner if that's how you want to get your data into your program. So happy day for us, right? So we're going to demonstrate how to do that. So we're going to read our arg array in and store it as an array of strings, and then we're going to sort whatever we got passed in. And I'll demonstrate how to set up IntelliJ so that when you run your program, that it will actually pass those values into us, so you don't have to type them in every single time. Okay, so sorry, I'm thinking ahead, trying to make sure I organize the code in a way that makes sense. So let's see here. We're going to copy our data from args, and there's a way we could copy it. I'm going to demonstrate both ways, and then you can use the way that you think is easiest. So I could say I need an array of strings. So string array data, that's our variable name, equals new string, but I don't know how long it's going to be. I could just say args.length, because args is already an array of strings. So there we go. And then I could say for, but I can't use a for each, because I need that index to be able to put it in the right slot in our new empty data array. Because where in the other example where it was filled with zeros, because we're storing strings, it'll be filled with null, meaning there's no value here. So we do need to initialize a value. So I'm going to say for int I equals 0, I is less than args.length. Args is our variable up here, I++, then I'm just going to say data sub I equals args sub I. So that's that's an array copy mechanism. So there's a little bit of a faster way to do this, where we could actually say, I could say string array data2 equals arrays, which is a special class in Java. It's talked about in the book, and I mentioned that you probably want to get familiar with this class that's described in the book, because it's got a ton of useful methods for working with data that's in arrays. We're going to say arrays.copyOf, and we're going to pass in our args array, and then we're going to say how many of those args we want, and we're going to say args.length, because that'll give us all of them. So that's a way that we can copy our data as well. Now, because we're going to be working on strings in this example, and our args array is already a set of strings, well, that's a bonus for us, right? Because we don't actually have to do any of this. We could simply say string array data equals new, or equals args. So you can assign a variable, it's the same type, right? So this data is an array of strings, and this args is also an array of strings. So we could just do that. But I'd actually I prefer to have a copy of it, because this memory is off in some protected place. And if I operate on that memory, I'm sure I'll be okay because I'm a good programmer, but if I'm not, I might mess something up. So we're just gonna make a copy in our own program space for it. And this technically is in our own program space, but it's on somebody else's stack. And I would rather have it in, it's in, the reference to it is on somebody else's stack. So we're going to make our own copy by using our arrays.copy of args and args.length. Okay, so now we have our data, and the data are whatever they are. So now we're going to write an algorithm that sorts them. So we're going to do, and this is our bubble sort, we're going to do a for int I equals 0, I is less than data.length, I++. It's a standard for loop. The reason we're not using a for each loop here, though, is because we actually need the I index, because we're going to use it to replace values in the array. So we need to know the exact index. And then for every I, or every element I in data, we need to check it against every other element after it in the array. And so we're going to say for int j. You can name your variables anything you want. I have the habit of using I and j for quick little things, using when I'm just indexing an array. You can name them anything you want. So we're going to say, and actually we want j to be the value next to the I value. Int j equals I plus 1, while j is also less than the data.length. And then we're going to say j++. So this means for every element I in the array, we're going to check it against every other element j in the array that comes after it. And then I have an if statement that says if, so now in the sorting algorithm, if the element that comes after the I element is smaller than the j element, or than the I element, then we need to swap it so that it takes I's place, because it's the next smallest thing in the array. And so the reason they call it a bubble sort is if you visualize the array, the sort happening, you can see the elements kind of bubbling until the smallest number in the array always getting put in its right place, and then it just kind of works its way through to the end of the array, but everything's bubbling back and forth. So, but you'll see kind of how this algorithm works here in just a second. So if data sub j is less than, but we're doing strings, so we can't use the less than. We actually have to use compare to, and if we don't care about capitalization, we can use the ignore case. Compare to, ignore case. So what this method does, and we actually need to say data sub I, what the compare to method does on a string is it returns 0 if the strings are equal. And it returns a number that's less than 0 if the left side number is less than the right side number. So data sub j would be the left side number, and data sub I would be the right side number. So if data sub j is less than data sub I, compared to ignore case will return a value that's less than 0. And of course, if data sub j is greater than data sub I, then compared to ignore case will return a number that's greater than 0. So now we've determined that we need to swap. So here's how we'll swap. We'll create a string to hold our variable here. String temp equals data sub I. So we're gonna hold that out in a temporary variable, and then we're gonna swap I and j. So data sub I equals data sub j, and then we're gonna put the I, what was I, our temp variable now, into data sub j. Oops. So voila. And then our inputs at the end of this double for loop, our inputs are going to be sorted. So if we say, now we can do our for each loop, for string s in data, we will do a system.out.println s. So if we run this, oops, that's going to do our creating arrays. Let's practice what we preach here. And let's click on it once so that we get a run creation or run configuration set up for it. That's actually going to become important in just a second. So bubble sort demo, and we ran it and it's done. We didn't really have anything to do. There was nothing to sort. And because there was nothing in the array, because we didn't pass in any arguments, then the array, our for each, had nothing to print out. So, and technically what happened is, let's actually set a breakpoint and debug this so we can see what happened here. So args.length was 0. So when I step over this line of code, now I have data, and data then becomes an array of length 0 because we told it to make data a copy of args. Okay. So then if I say for I equals 0 while I is less than 0, well, that's going to bail out on the first pass. And I'm going to say for every string that's in data, well, there's nothing in data. So I'm going to skip that. And we had it basically, the program ran completely successfully, but it did nothing because we gave it nothing to work with. So now this is where we will be able to add, this is how we can actually run the program. So first I'm going to go to terminal. I'll get out of JShell here. And let's find where our code is. Our source code is in our source directory, and IntelliJ puts our compiled source code into a directory called out. And if I look there, you'll see here, I've got my bubble sort demo class. So I can actually run this program by hand by saying Java bubble sort demo. And then when I hit enter with no commands, I'm going to see that it just ends. And that was the case that we just saw in the debugger. But now if I pass parameters to it, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm actually going to come over here really quick and I'm going to copy this text because I don't want to type that every single time. And you look at that. It sorted it E, F, N, O, S, 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 T, 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 T. So it sorted them. Why did it sort them in alphabetical order? Because that's all we can do with strings. So if I were to actually come back here and run the program with 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I do 10 and 11 and 12, look at the sorting. I got 1 and then 10, 11, and 12. So we've told our algorithm it's only working on strings. It has no idea that the strings actually hold things that could be numbers. So it's sorting them alphabetically by their ASCII values rather than numerically. If we wanted to convert these to numbers, we would have to write code that converted the string to an integer using integer.parseInt. But I just wanted to show that to you really quick. But now, how do we get our inputs so that we can still run the debugger and run the program by clicking up here? Well, now we come to our run configurations, and we can edit configurations, and we'll come to our bubble sort demo, and you'll just a quick little tour of this. We've got our main class and our VM options. That's things we could pass to Java itself to tweak how it runs, how it allocates memory. We're not going to do any of that in our class, of course, but we actually make use of this quite a bit professionally because depending on the type of application you're writing, we might need more memory or less memory than Java gives a program by default. And so we would do all sorts of things here with these VM options. We're not going to go into this. Environment variables are also variables that your computer sets, like your path that we had to set to make sure we could run Java and JShell in the terminal. That path is an environment variable. So you could actually create other environment variables, and your program has access to those. But the thing we care about most here is program arguments. This is a space-separated list of strings that we will pass into our program, and this is what becomes our args array. And like I said, it's space-separated. So if you need to have a space in a value, then I could say 100, and I could wrap it in quotes, either single quotes or double quotes. It doesn't matter. But if I do that, then then the command line parser will treat it as one value, and this internal space won't cause it to be separate values. So now I've said that, and it might be that my terminal does that for me, but we're going to find out in just a second together. So now we're going to run our bubble sort demo, and we should see our sorted values. Look at that. And look, see, our 100 came in just like we thought it should. So that's our bubble sort. So that's pretty cool, right? So our bubble sort works. We've seen how to create an array. We've seen how to copy an array from one array to another, and so you don't have to operate. See, the problem is if I had done this array here, if I'd worked on args, then I'd be sorting my args, and maybe I don't want to sort my original source of data. And so I created a copy. And we've also now shown how to access individual elements. We've shown how to move one element from one spot to another. And you know, if you're going to swap the two in Java, you need a temp variable to do that with. So that's not a big deal. And then there's one other thing I wanted to illustrate to you about passing by reference and passing by value. So I'm actually going to take my bubble sort algorithm and move it to a method. So I'm going to say, just a second, I'm going to create a method. We're going to say public static void, because this doesn't return the method. It doesn't return data. It simply operates on the data that's passed into it, because it's going to be passed by reference. Because arrays are, as we said, the memory for the array, when we do a new, and our array.copyof does the new for us, it actually goes out and creates a place in memory to hold that data, and then it returns a pointer to it. And a pointer is like a double or a long data type that points into memory. If you think, you can think about it that way. And so what we pass into a function or a method when we pass an array is the pointer. We don't pass the actual data held in the array because it could be huge. So we pass the pointer to the array. But that means that the method can operate on the actual array data itself and not a copy, like when in last week when we talked about pass by value. So we're going to call this our bubble sort function. And it's going to take in a string array of data, because I'm not real creative in coming up with new names for the same thing. So this data is different than this data because they're in separate methods, two separate scopes. So I can have the same variable name because they're in two separate scopes. And then we will simply grab this code here and paste it in here. And then we'll call the bubble sort method up here. So we'll say bubble, and we will pass it our data. And this will run our program the same as it had, because now that since we've edited our configuration here, it's going to stay that way. And we can make sure it stays that way if I'll just save it like that. So then we'll run our bubble sort, and voila. Okay, so that was this, without even trying to necessarily, our bubble sort has demonstrated that we pass by value, or pass by reference, sorry. We'll add a comment here, bubble sort. I do want to have another method that actually will create a copy of our data for us before we sort it. So we're going to say public static void bubble sort with a copy. I don't need an underscore there. We'll just say bubble sort copy, and we'll say string array data. And this is going to be cool because this will show the point. First, I'm going to copy my data. So I'm going to say string array copy equals arrays.copy of, and we'll say data and data.length. Remember, I don't know what the length is because the user can type as many command line arguments as they want. So I have to use data.length. I can't use any kind of hard-coded number. So there's my copy, and now I'm going to bubble sort my copy. And actually, if I just do this, then outside of my method, whoever calls bubble sort copy won't actually have access to it. So I'm going to make this method return my copy, and I will say return copy. So this will actually be a really cool demonstration. So we're going to bubble sort that data, and then we're going to let's make a copy of our args again. So we're going to say data equals arrays.copy of args and args.length. And then I'm going to say string array copy equals bubble sort copy. And I'm going to pass in my data. But now I'm going to do something interesting to show you how they're different. So we're going to do a for each loop. We can say for string s in data system.out.println s. Then we're going to do a for string s in copy system.out.println s. So when this program runs, and let's put a label in front of everything here, system.out.println sort data pass by reference, and then we'll say system.out. Oops, we need a semicolon up here. System.out.println sort data with copy first, and this will be our original data. And then we'll grab this line, and we'll print this again, our sorted data. So let's walk through this and make sure we understand what we're going to see in the results. So we come in, and whatever the user gave us on the command line, we're going to make a copy of that and store it in data. We're going to bubble sort data. So with a pass by reference in the bubble sort method, because it's an array, not because of the way we wrote bubble sort, because arrays are always passed by reference, our bubble sort method works on whatever array we give it, and it changes it. And so our data array that was a copy of args is going to be changed. So it's going to be different than args. So then we're going to print out the values, and we'll see them sorted. And then we're going to copy args again. And so args, and the reason why I copied args to begin with, because I knew I was headed this direction with this example, is that args is still the original data, so it's out of order. And then we're going to make another copy of it. We're going to call bubble sort copy. So then we're going to print our original data that got passed into bubble sort copy, and it should be args. It should be our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100. And then the copy is what should be sorted, where 8 comes first. So let's run this program, and we'll take a look. It happened nice and quick. So sort data passed by reference, 854 night. Did I actually do that? I did that. You're probably sitting up there again saying, Brother Anderson, you're such a dork. 8, 9. There. It's probably been bugging some of you that I typed night there and didn't notice it. So we'll run our program again real quick and get new output. All right, so there's our sorted list. But now here's our sort data, 1, 2, 3. And I passed that into my bubble sort copy, but because bubble sort copy makes a copy of the data before it sorts it, then it didn't change the original array. And we can see that now because we're printing this out after this copy. But the copy did get sorted. So that's pretty cool. Now we're going to do one last thing in the debugger just to show you what pass by value, pass by reference actually means. So in my main, you can see here, my main has args, and my args is a string of 11 values. You can see that there, and that's how many values we put in on our command line. And it's at memory location 773. That's how Java addresses memory for us. So, and that's nothing we ever care about except when we're debugging and trying to figure out what's going on. So just keep in mind that our args array, this thing passed into us in main, is at memory location 773, but we're going to make a copy of it now. So after we copy, then we'll see here that data is now an array at memory location 779. So they're different spots in memory. They're pointing to different variables. So we're going to go into our bubble sort. We're going to pass it our data array. And so when we go into bubble sort, now we see that our data variable here, and we just named it the same because I didn't want to waste time trying to think of a more creative name. And it describes exactly what it does. So no point finding a better name from a good name we already have. But you can see it's still 779. So out here in our main method, it's at 779. And also inside our bubble sort, it's also 779. So that means any changes we make to it are going to be made to this spot, to the variable held in this spot in memory. So we'll run through our bubble sort algorithm, and we're going to just run to the line here. And I think actually we'll put our cursor here. And we're going to run to cursor, and that puts us, I think our program ended. It did, because there wasn't a line of code to stop on there. But let's do that again. All right. So we've got our copy, step into bubble sort. We're going to do our bubble sort thing. We've already looked at our memory, and now if I just step out, we'll go back, and then we can do our print lines, and we'll just walk through. And you can see we're working on data, and that data is still our 779. So that works nicely. And let's see what S is real quick. What does S? S then becomes a string, and if we look into it, you can actually see that its value is a byte array held at memory location 782. So this is in some relation to our to the data at 779. So as we continue to walk through, we can see that we've modified the data. Anyway, so that is pass by value, pass by reference. Oh, but what we didn't see was bubble sort copies. So let's go do that. So step over. When we called bubble sort copy, we're going to right click and run to this cursor. There is a line of code here, so we'll stop here. So now let's step into our bubble sort copy. So out in bubble sort demo, our data is at 782, our args are at 783. And so 782 comes in. So our data is what we passed in, 782. But now I'm going to make a copy. And copy is at 783. And then when I pass copy into bubble sort, what do we expect? We expect 783 to come in, which it did. So now we know we're operating on our copy of the data. And we'll exit out of here, and then we do our printouts, and everybody's happy because our printouts are what we expected them to be. So we can see here, we sorted the data passed by reference, we sorted the data with a copy first, and we're all done. So that is a demonstration of how to use arrays, how to manipulate, access and manipulate the values in an array. We're not going to give an example of multi-dimensional arrays. Like I said in the announcement, we're not really going to do much with them. And if you run out of time this week and you can't read chapter 8, then it's going to be okay. We'll survive without it. We do use multi-dimensional arrays when we start talking about numerical analysis and statistics and machine learning. Those are areas where they become more important. So as you get deeper into your studies and you get into those topics, you'll at least understand that arrays can have multiple dimensions to them. All right, the one last demonstration, and this is just for fun, is to illustrate the fact that this loop that it takes a pass through the loop for every element in the loop. So that means we run that loop if the array has length n, and we do this bubble sort algorithm, we're going to run n times n times through the loop. So if we have 10 elements, we're going to run through the loop 100 times. And so for small amounts of data, a bubble sort is absolutely fine. It works great. It's as fast as anything else. But for large amounts of data, bubble sort is extremely slow. And there are much better, faster, more sophisticated algorithms that we can use. And one of these algorithms is built into Java for us, and it implements it using what's called a dual pivot quicksort algorithm. It's not all that complex. It's actually really ingenious how it works, but you're going to see that it is so much faster than our bubble sort. So this little demonstration program is going to create a random, or it's an integer of 100,000 variables, or 100,000, sorry, it's an array of 100,000 random integers. So here we'll see, we're going to walk through this so you can see more array operations. I have my array size that's a constant, because then I just have to change one place if I have to worry about what the array size is. Once the array is initialized, I don't have to worry about the array size. In fact, what I should do here, since data is already initialized, I should be saying data dot length. Okay, so I only had to use array size in 2 places, but that's one more place that I want to have to change. So we create an array of 100,000 slots, and then we walk through all 100,000 and we stick random integers in there. This part of the program takes no time at all. But then we do arrays copy of, we're going to actually copy the value, because if I call my bubble sort algorithm, which I've implemented a bubble sort for integers down here. If I call my bubble sort algorithm, it's going to change the array, and then if the array is already sorted, then that would make this one look really fast, but that would be artificial. So I make a copy of the original random array so that both algorithms are going to be tested using the exact same input in the exact same order. So then I print out my little label, and then I measure the current time in milliseconds before starting the bubble sort, and then I will run the bubble sort, and then I'll measure the current time after the bubble sort ends, and then that'll tell the end time minus the start time will tell me how many milliseconds that algorithm took to run. And then I'll do the same thing with the Java sort. And the Java sort simply calls the arrays.sort method and passes it our array of integers. And I think you're going to be amazed at this. I'm going to start the program. It's going to run. It's going to run for a minute with nothing happening. So as we watch this, I'll take advantage of this time doing the bubble sort to get a drink of water. That was a great drink of water, but we're still waiting for our bubble sort to return. So what's 100,000 times 100,000? Anybody want to do that math real quick? Oh, it doesn't matter. I mean, I guess it took 17 seconds almost, 16.957 seconds to sort 100,000 random integers using a bubble sort. And it took 20 milliseconds using Java's built-in sort algorithm. So which one do we want to use when we're dealing with real live production data? Of course, we want to use the Java sort. We used a bubble sort just to demonstrate how we could work with array data. And a bubble sort for a small amount of data would be fine. But if you really want to, if you've got a large amount of data and you need to sort it fast, we wouldn't use a bubble sort. We'd use the more sophisticated sorts that the programming language provides. So that's about it. But I guess let's just do a little bit of math. 100,000 times 100,000. So we ran through, is that right? We ran through that algorithm in the bubble sort. We ran through that array 10 billion times in 17 seconds. That was pretty cool. 10 billion, 10 billion. So we sorted 100,000 items in 20 milliseconds versus running through the array 10 billion times in 18 seconds or 17 seconds. So pretty good. Anyway, that does it for this week. I look forward to your questions. I hope that you will ask them early in the week, and we can help you get your understanding of arrays down, and then we can focus on getting the assignments done. And like I said, you are welcome this week to use command line arguments for your arrays for populating the values, or you can use a scanner and prompt the user for it. Either one I will accept, and if you need help getting it set up, just ask in the discussion boards or send me a note and I'll be glad to help you. Thanks, goodbye.